Hi, so a few of you have had a question on this, so I wanted to just put this out there. You can ignore this. If you did the limits practice 2, number 3, and you're like, I'm a boss, I got this, keep going through this video and go about your day. But if you had a question, I'm hoping that I can clear up a little bit confusion and that you can say nicer things, because I'm guessing in your head you may have been cursing me out or giving me thumbs down, which probably would have hurt my heart. Either way, I can take it as long as I don't know about it. So just to help you out on this one, in part A, the question in number 3 is asking about the difference quotient. The difference quotient sounds terrifying. It's not that bad. I'm sorry. I'm trying to scroll down my keyboards over there. Difference quotient that best approximate the instantaneous rate of change. So instantaneous rate of change, we talked about this a little bit in the very first lesson. It was talking about gas mileage at different places. But anytime you're talking about a rate of change is also just a slope of some sort. So I'm thinking about, okay, I'm estimating the slope. A difference quotient though, what's that business? Difference means subtract. Quotient is the answer to a division problem, or we can write this as a fraction. And we just said instantaneous rate of change was also slope. Think about the slope formula. That's y2 minus y1. This is a difference quotient. It's just you want to fill in the numbers. So if you're talking about g of 4.5, you're going to want to put something like g of 5 minus g of 4. I didn't actually calculate what that was yet, but this is my work. G of 5 minus g of 4, 5 minus 4. And you can type that as best you can in there. If you want to send me a picture or something of your work and just say, hey, I sent you a picture, you can do that too. The second one, if you have not watched the video from 9:10 yet, stop this now, go do that work instead. So this, for first period students, I'm sorry, this was kind of mean of me to do this right now. I was trying to get my days right, but you definitely should have watched this one before you tried to B and C. For sixth period, you're fine because you won't do this until tomorrow, and then by that point you should have already watched the video. Okay, so this one says the limit as x approaches 4 of h of x, and limit as x approaches 4, and this is of g of f of x. So this is a composition of functions. So for this type of problem, you'll learn in the video, if you haven't already, that you have to do the inside out. So I'm going to say, well, what is the limit as x approaches 4 of g of x? Or I'm sorry, of f of x. I can read. Okay, so f of x, that's the graph on the left. If you approach 4 from the left, you have to find that limit first. Then after you find that limit, you can say, okay, I feel like I just need to tell you. Do you see how it's 2? Because from the left and the right, the values of f of x are approaching 2. Which means now I look, limit as x approaches 2 of g of x. If I go over to 2, oh no! You can see, if you're looking on yours, at least I hope you are, since I'm not showing you what this graph looks like, I can see on mine that if I say the limit as x approaches 2 of g of x, from the left and the right, I could say right away does not exist because these aren't equal, but that would be wrong. Because the limit as x approaches 4 of f of x, that is happening, and all of these values are approaching from below. So I get 2, but from below. And again, I go into great detail in the video. But if I'm talking above and below, that's where this problem's coming into play. So I'm saying, what is the limit as x approaches 2 from the left of g of x? So I realize that I'm not going into detail here, but I did it in that other video, and I want to keep this one short. That's what you should be paying attention to. This is one of those above-below situations, and that's why this limit is a little bit different than you might think. In part C, if you said the limit as x approaches 2, and I realize there are other ones, but this one is where it's going to look a little funky. If you said the limit as x approaches 2 of f of x, you might just be tempted to say does not exist because the limit as x approaches 2 of f of x, the left doesn't equal the right. Don't do that. Go a little bit further in your investigation and find the limit as x approaches 2 from the left of f of x, limit as x approaches 2 from the left of g of x, and see if that's equal to the limit as x approaches 2 from the right of f of x, and the limit as x approaches 2 from the right of g of x. Sorry, I know that's getting in there. These are going to be equal, but you have to do it a little bit work. Again, that's from the video, but it's just making sure the left-hand limit is equal to the right-hand limit, because that's when limits exist. So that you know what a jump discontinuity is, because that comes up in a couple different problems, a jump discontinuity would be like this. So let's say I've got some x value a. Ooh, there you can see it. A jump discontinuity would be if I have a piecewise function and it actually jumps from one location in the graph to the other. If there was just a point down here, but it was the same on both sides, so like something that looks like, oops, not that, sorry. I was trying to do that. The left and the right are equal. This is not a jump discontinuity, even if there's a point down here. So that's vertical line. I don't know why I drew that, but this is a jump discontinuity. I hope that helps. Thanks for being awesome. Remember to try to practice first. If the practice problems are going to be a little bit easier, and some of you have been saying that you want more practice. I know your time is really valuable, so if you're ready for the AP Classroom things, do that first. There's a lot of trig practice in the practice problems that I gave you today. If you're like, oh, I think I can just do this, I can skip right to the AP Classroom ones. They're going to be more AP level questions, so they're going to be more difficult, but I want you to be hearing that language right now, like how they speak, and then be able to be a boss and speak yourself. Okay, thanks so much for being great. Bye. Let me know if you need help. Bye.